Welcome to Abdemi's YouTube platform. We'll consider problem, MCQ type problem from chapter Oscillation. See, what is the problem? Statement of the problem is a particle of mass A is executing oscillations about the origin on the x-axis. Its potential energy is Vx equal to K mod x cube, where K is a positive constant. If the amplitude of oscillation is A, then its time period T is, which one is correct out of four options that you have to find out. Now, the particle of mass m is executing oscillation about origin on x-axis. This is origin, this is x-axis, and its potential energy Vx is given as K mod x cube. K is a positive constant. If the amplitude of oscillation is A, that means I can assume that this is x equal to A point, this is x equal to minus A point, negative A point. That means the particle is oscillating between these two boundaries, x equal to A and x equal to negative A. These are the 2 points, extreme points, and this is the center of oscillation, midpoint. Alright. Then, and mass of the particle is m, and potential energy is given by this. Now, there is a easy technique to solve this particular problem. We assume that we will use a dimensional method to solve this problem. Let us assume that period T of oscillation is proportional to m to the power x, k to the power y, and a to the power z. So 3 parameters: mass, k is this constant, and a is the amplitude. And we assume they are specified in this problem. Let us assume that period of oscillation is proportional to mass or is related to mass by this relation. T is proportional to m to the power x, T is proportional to k to the power y, and T is proportional to amplitude to the power z. X, y, z are numbers which are to be determined. Standard dimensional technique we do like this. Now, this is potential energy. Now, what is the dimension of K? So, dimension of V is that of energy. And energy, you think energy, what is the unit or dimension of energy? It is mass into velocity square. So it is m L to the power 2 to the power minus 2. This is the dimension of V. Now kx cube mod x cube, what is the dimension of this? So it is k, dimension of k multiplied by L cube. L represents length, m represents mass, and t represents time. So, what is since this quantity is equal to this quantity, so dimension of left hand side quantity should be equal to the dimension of right hand side quantity. So, I can think k L cube must be equal to m L square to the power minus 2. So k's dimension should be equal to m L square to the power minus 2 divided by. So it is m l to the power minus 1 to the power minus 2. Is it okay? So how it comes? Vx is the potential energy. Energy's dimension is mass into velocity square. Mass dimension m and velocity length by time whole square. So m l square to the power minus 2. Now kx cube's dimension is dimension of k multiplied by length cube. Therefore, both dimensions are equal for this equation. If you take left hand side and right hand side, the dimensions of left hand side quantity should be equal to dimension of right hand side quantity. So KL cube must be equal to m l to the power minus 2 into t to the power minus 1. This is t to the power minus 2. This is the dimension of V. M L square to the power minus 2 must be equal to K L cube. So K's dimension will be m L square to the power minus 2 by L cube. So m L to the power minus 1 to the power minus 2. Now, from this expression, dimension of T is T only, whereas dimension of m to the power x, k to the power y, dimension of k is this much, so dimension of k to the power y will be m to the power y, l to the power minus y, and t to the power minus 2y. Okay, and a is actually amplitude, whose dimension is length. So its dimension will be L to the power z. So T is equal to some constant C multiplied by m to the power x, a to the power y, a to the power z. So dimension of T should be equal to dimension of this quantity. This is a unitless quantity, it's a pure number. So dimension of m to the power x is m to the power x, dimension of k to the power y is m to the power y, l to the power minus y, and t to the power minus 2y, and a's dimension is length, so a to the power z's dimension is l to the power z. So it is what? M to the power x plus y, l to the power minus y plus z, t to the power minus 2y. So, since there is no m this side, so I can write easily x plus y must be equal to 0, implying x equal to minus y. There is no L in the left hand side, so minus y plus z equal to 0, implying y equal to z. And t to the power minus 2y, since here t to the t's power is 1, so it should be minus 2y equal to 1, therefore implying y equal to minus half. Okay. Then z is, since y is minus half, already have found, so z must be equal to again minus half, and x must be equal to half. So t, from this expression, t is proportional to a to the power z, but z I have found minus half, so t is proportional to a to the power minus half. That means t is proportional to a to the power minus 0.5. That is, t is proportional to 1 by 2 power a. So the correct answer is this one. Period t is proportional to a to the power minus 0.5, or t is proportional to 1 by 2a. So this is the correct answer. So answer is A. So by simple dimensional analysis, we could solve this problem. I hope it is clear. Simple thing is potential energy is given Vx equal to K mod x cube. So dimension of Vx should be equal to dimension of K mod x cube. From this, dimension of energy is m L to the power 2 to the power minus 2, and dimension of Kx cube is dimension of K multiplied by L cube. So KL cube must be equal to m L to the power 2 to the power minus 2. So dimension of K will be m L square to the power minus 2 by L cube, which is m L to the power minus 1 to the power minus 2. So this part we have done. Now we are assuming that period is proportional to m to the power x, k to the power y, a to the power z. Okay, so dimension of T should be equal to m to the power x. This is mass. Then k to the power y. K we have already found m L to the power minus 1 to the power minus 2. So it is m to the power y, L to the power minus y, t to the power minus 2y. And a is the amplitude which has dimension of length. So it is L to the power z. Dimension of a to the power z is a to the power z. So it is m to the power x plus y, L to the power z minus y, and t to the power minus 2y. And this side, left hand side, it is period which has dimension of time t. So I can write, since there is no m, so x plus y must be equal to 0, from which x is negative y. Then L, there is no L also, so minus y plus z must be equal to 0. So y is equal to z. And then t to the power minus 2y, and this minus 2y must be equal to 1, which gives y equal to minus half. Since y equal to minus half, z equal to again minus half, and x equal to minus y, which is plus half. So t is proportional to how much? T is proportional to a to the power z. Actually, t is proportional to m to the power x. So t is proportional to m to the power x. I have already found half. So t is proportional to root over n. Then t is proportional to k to the power y. Y is how much? Minus half. K to the power minus half. And t is also proportional to a to the power z. But z is actually minus half. So a to the power minus half. So t is proportional to a to the power minus half. So this is the correct answer. So this is one way of solving this problem. But we will solve this problem in a different manner for more insight into the problem. This is a conventional technique and you can easily arrive at the solution, and in exam you can follow this method safely. But to have a clear understanding of the problem, I will discuss another approach to solve this problem. You may find it interesting. Please try to follow what we are doing. It is little bit lengthy, but it gives more insight into the problem. So you know, potential energy is given as K mod x cube. X is the displacement of the particle which is executing an oscillation, having amplitude A. That means in the x direction it goes a maximum distance up to A plus A, and negative x direction it moves up to this boundary, x equal to negative A. So it is oscillating between these two boundaries. Okay. Now Vx is K mod x cube. Vx is the potential energy, and you know the force acting on the particle can be derived as minus Fx equal to minus dVdx, negative gradient of potential energy. How it comes we discussed in a previous class, you must be remembering. So now here it is Vx equal to mod K mod x cube for x greater than 0, greater than equal to 0. We know mod x is actually x, and therefore Vx is Kx cube, and therefore Fx, the force acting on the particle when it is in positive part of x-axis is how much? Negative dv dx. Negative dv dx is how much? It is minus 3k x square. And for x less than 0, mod x, you know, by definition it is negative x. And therefore, Vx is actually minus k x cube. So Fx is how much? 3k plus 3k x square. So the force acting on the particle when x is greater than equal to 0 can be written as this, and when x is less than 0, the force can be expressed like this. So how the force looks like if I draw the graph, plot Fx versus x. Okay, so when x is greater than 0, Fx is minus 3k x square. So it will be like this parabolic shape. There is no doubt, hopefully. And when x is less than 0, Fx is 3k x square. So parabola shape will be like this. So this is x equal to 0 point, and this is x-axis, and this is Fx. So plot will be like this. In case of simple harmonic motion, you know Fx is minus kx. So in case of normal simple harmonic motion, if you recall, the force versus x curve is something like this. You recall that? Normal simple harmonic motion, but here it is a non-linear curve. It's passing through origin, obviously. So what is the character of this motion? As the particle moves in this direction, there is a force acting on the particle in the negative x direction, and as a result, the particle acquires a retardation sort of thing, and its velocity reduces, and when it reaches this particular point, extreme point, its velocity becomes 0. So its velocity u becomes 0 when the particle reaches the point A. Similarly, when the particle moves along negative x direction, then the force is acting in the positive direction, and force when the particle is approaching along negative x-axis, there is a force towards the center. As a result, it gets retarded, and after reaching the extreme point minus a, again its velocity becomes 0. So it makes a to and fro motion, and we can, from symmetry consideration, you can say whatever time it takes to reach from this point to this point, it takes the same time to reach from this point to this point, again from this point to this point, same time, and then it takes same time to come back to O. So if I assume that T1 is the time the particle takes to reach from O to x equal to A point, or 0, x equal to 0 to x equal to A point, then it takes, the period will be actually 4 times T1. T1 is the time the particle takes to move from x equal to 0 to x equal to plus A. Okay, and the period will become t equal to 4 times T1. Now our objective will be to find out T1. I am doing a rigorous calculation. So Fx is, say for example, when x is greater than equal to 0, Fx is given as negative 3k square. So the acceleration of the particle when x is greater than equal to 0 can be written as ax equal to minus 3k by m x square. Okay, so acceleration is what? Rate of change of velocity. So I write it du dt equal to minus 3k x square. Alright. Now by m, 3k x square by m obviously. Up to this there is no doubt. Now du dt I can write by applying chain rule ddx of du dt sorry. Now what do we do? Du dt is ddt of dx dt. This is acceleration. So it is ddx of dx dt into dx dt. I can write this from chain rule. Okay, so it is how much? Du dx into u. So I can write it is u du dx. So acceleration of the particle is actually u du dx. So u du dx I can write u du dx is equal to minus 3k by m x square. Alright, or I can write u du is equal to minus 3k by m x square dx. Up to this it is clear? Okay. Now let us work out further. So I will try to find out what is u. So u, you see u, if you integrate this expression both sides, so what happens? It is u square by 2 is equal to minus 3k by m x cube by 3, so it is becoming minus k by m x cube plus some constant of integration a. Now we have already discussed at x equal to class a, u becomes 0 because it is the amplitude. Okay, a is the amplitude. So as the particle moves along positive x-axis, there is a restoring force or retarding force which tries to bring the particle back to the point of equilibrium O. As a result, retardation is produced. As a result, its velocity decreases, and when it reaches A, the velocity becomes 0. So, and again, since there is a restoring force acting on the particle purely in negative x-direction, it tries to come back. It comes back along negative x-axis in this way. What happens exactly in synchronic motion? Only thing is that force versus x plot, they are little different in both the cases. In these two cases. So at x equal to plus a, u equal to 0, this yields what? This 0 equal to minus k by m a cube plus a. So a becomes k by m a cube. So u square becomes minus 2k by m x cube plus 2a, that is 2k by m a cube. So it is how much? It is actually 2k by m a cube minus x cube. So once we know this is u square, so from that what we can do, we can find the value of u. So u will be how much? Simple. U will be root over 2k by m root over a cube minus x cube. So dx dt, u is nothing but dx dt, rate of change of position, is equal to 2k by m root over a cube by minus x cube. Remember, all these things we are doing for x greater than equal to 0. Then velocity can be given like this. So root over 2k by m dt is equal to dx by root over a cube minus x cube. Now this quantity, if I integrate, when time t changes from 0 to t1, the time it takes, the particle takes time t1 to reach from O to A, x equal to a point. So if I integrate from 0 to t1, then this side I have to integrate from x equal to 0 to a. When the particle is at x equal to 0, the time is 0, and when particle reaches x equal to plus a, the time becomes t1. Alright, now, okay, now we want to do further calculation on this. What we can do, see. So these are no more required, we just remove all this. I hope you have already understood how the graphs were drawn. So, see what is happening. So it is 2 root over 2k by m t1 is equal to integral 0 to a dx by root over a cube minus x cube. Let x equal to a sin theta. There is no harm in taking like this, because x value, when x is greater than equal to 0, x value is always a number between 0 to a, and therefore I can safely write x equal to a sin theta. So dx is equal to a cos theta d theta. And you know, since you have changed the variable from x to theta, so limits of integration also will change. When x equal to 0, theta is also equal to 0, and when x is equal to a, theta is actually, sin theta becomes 1 and theta becomes pi by 2. So I can write this integral as 0 to pi by 2 dx. I can write as a cos theta d theta. So let me remove all these things. So remember, we are doing all this calculation when x is greater than equal to 0. I hope there is no doubt about it. So let me just rewrite. We are doing all this calculation when x is greater than equal to 0. So dx is a cos theta d theta divided by a cube minus a cube or sin cube theta. So it is a to the power 3 by 2. If I take outside square root, 1 minus x is sin a sin theta, so sin cube theta. Okay, so it is 1 by square root of a 0 to pi by 2. So T1 becomes root over m by 2a 1 by root a integral 0 to pi by 2 cos theta d theta by 1 minus sine cube theta. Now this integral, I am not evaluating this integral. This integral is a pure number because this is a function of theta only, and if you integrate, it will be another function of theta. And when evaluated in the interval 0 to pi by 2, this gives a pure number. So Q1, and we have already learned that T is equal to 4 times Q1. So T is proportional to square root of n. T is proportional to 1 by square root of k, and T is proportional to 1 by 2k. So we have been asked to tell about the dependence of T on A. So T is proportional to 1 by 2 over A, that is T is proportional to A to the power minus 0.5. So this is the answer. So it is a bit rigorous method, but I have just shown so that you can understand what is the concept behind it. Okay, but in exam you should definitely solve this problem using direction analysis. It is very quickly you can arrive at the result. It is a detailed analysis. So I hope you have understood how the rigorous analysis also can be done for solving this problem. So if they ask what is the dependence of T on mass, then it is the dependence. What is the dependence of T on K? This is the dependence. And what is the dependence of T on amplitude? This is the dependence. So all these three things you can find out. Okay. So I hope you have understood the problem. If you have any doubt, please revert back to us. We will try to explain it further. So thank you for kind listening. Thank you very much.